Alright, g'day everyone. In this video we're talking about combinations of objects. So the difference between a combination and a permutation is that permutations, the order matters, whereas combinations, the order does not matter. The order does not matter. Okay. For example, if you're randomly picking fruit from a fruit bowl, it doesn't matter if you pick out an apple and then a banana, or a banana then an apple. The result is essentially the same. You've got a banana and you've also got an apple. It doesn't really matter which one came first. So that's sort of the idea of a combination. It doesn't matter which one came first, doesn't matter which one came second. So let's think a little bit about arranging A, B and C, these three letters, into a bit of a row of three. Now we know that you could do that in three factorial ways. You know, you could have A, B, C. And 3 factorial is 3 times 2 times 1, which is 6. So there's one option. It's going to take a while. 3 ways, 4, 5, 6. Okay. So you could also have A, C, B. You could have... Oh, actually... Alright, let me give up that example. That's going to be a bit of a nuisance waste of time, because with each of these ways you're still going to have A, B and C. So you're always going to have the same 3 all the time. So there's actually only one combination of these. Now suppose we were arranging A, B and C only into pairs, okay? Different possible pairs. That would be much more interesting. That would be like doing n number of objects is 3, number of spots is 2, so that's a 3p2, or also known 3 factorial over 3 minus 2 factorial. 3 minus 2 is 1, so that's just 3 factorial. So let's check this out. This will be like an A and a B, or it could be A and C, or it could be B and A, or it could be C and A, or it could be B and C, or it could be C and B. They're our only options, but A and B is the same as B and A in terms of the combination. And similarly, A and C, that's the same as this one, and these two are the same as each other. So we actually have 3 factorial divided by 2 factorial, because there are 2 spots, and so they could be swapped around in different ways. So the general gist is, however many positions you've got, whatever your R is, you've got to divide your permutations by that R factorial to get a combination. So you've got to take out all of the different possibilities of them just being swapped, their order being swapped. So generally speaking, if we have n objects are positions, the number of combinations is, we write it using a C, not a P, and we say NCR. This is also written just like NR, which I'll show you in a sec. And it's given by n factorial divided by r factorial times n minus r factorial. So it's the same as our p thing, but divided by the r factorial. So there it is. Definitely write this down. It's very important that you know and understand it. So here's an example. How many ways can you combine 5 objects to display 3 of them? So that's pretty easy. In this case, we've got n being 5, we've got r being 3, and we're talking combination, not permutation. So that's just a 5c3, or another way of writing it is 5, 3, using these circular bracket things. So that's 5 factorial over 3 factorial, 5 take away 3 factorial. So that's a 5 factorial over 3 factorial, 5 minus 3, 2 factorial. There we go. And you can evaluate that, which of course in this case, the 5 factorial and the 3 factorial will make it just 5 times 4 over 2 times 1. So there you go. Let's finish that off. 20 over 2 equals 10. 10 different ways to combine 5 objects into 3 sort of positions. So let's do an example that actually uses this sort of in more of a real life situation. Imagine you were buying an ice cream cone. Here it is. You're lashing out and getting a double. Okay, double ice cream. And you have, let's say you have 6 flavors, and you can't repeat a flavor. You can't have 2 chocolates. That's just cheating. Okay, so in this case, it's an n equals 6. You've got 2 positions, as r is 2. So that's a 6c2. Doesn't matter if you've got banana and strawberry, or strawberry and banana, it's the same thing. So that's a combination. So that's a 6 factorial over 2 factorial, 6 take away 2 factorial. And then you can solve that fairly easily. So yeah, there you go. That's how the combinations work. Fairly straightforward, really. Okay, might as well show you how to do combinations on your CAS calculator. So let's check it out. Open up our CAS calculator. If we go menu, probability, combinations this time. Now, similar to before, here was our NCR, so put our number for n in first, let's say 6, and then R, let's make it 2. There you go. We had 15 for that, so our example here, if we had worked it out, would be 15. So there we go, there are our combinations. Now, let's do a few extra combinations on the CAS calculator, and you'll start seeing a bit of a pattern. So what if we had 0 objects, arranging them in 0 ways, in 0 positions? Then we have 1 possible way. So let me just write that down. 1. Okay, interesting. Okay, next up, what if we had 1 object arranged in 0 ways? Well, there's only 1 possible way you can do that as well. Okay, interesting. Now, what if we had 1 object arranged in 1 position? Oh, that's just 1 way that you can do that. Interesting. Okay, what if you had 2 objects arranged into 0 positions? Oh, only 1 way you can do that. Okay, fair enough. Okay, what if we had 2 objects arranged in 1 position? Oh, 2 ways you can do that. Fair enough. So, 2 ways. What if we had 2 objects arranged in 2 positions? Oh, 1 way you can do that. Okay. 1 way you can do that one. Okay, interesting. I might start speeding up a bit. What if we had 3 objects arranged into 0 positions? Okay, that one's 1. Let's just remember some of these. 3 objects arranged into 1 position. Okay, 3 ways you can do that. How about 3 objects in 2 positions? Oh, 3 ways. And 3 objects in 3 positions. 1 way. So we had, for our 3 objects, we have a 1, 3, 3, 1. Okay, let's jot those down. 1, 3, 3, 1. Okay, let's just do the 4s and then we'll discuss the pattern. Some of you probably seen it already. 4 objects, 0 positions, that's a 1. 4 objects, 1 position, that's a 4. 4 objects, 2 positions, a 6. 4 objects, 3 positions, 4. 4 objects, 2 positions, oh whoops, shouldn't have been 2, should have been 4. 4 objects, 4 positions, it's better, 1. So here we had a 1, 4, 6, 4, mistake, 1. So 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. Okay. 1, 4, 6, 4, 1. Now, hopefully you can see that this is actually Pascal's triangle. If you add these two, the 1 and the 1, you get 2. If you add 1 and 2, you get 3. If you add 2 and 1, 3. 1 and 3, 4. 3 and 3, 6. 3 and 1, 4. So here, without even doing it, I can go 1, 5. 4 and 6 is 10. 6 and 4, 10. 4 and 1, 5. And 1. And I can keep going, because it's like 1 plus 0, 1. 6, 15, 20, 15, 6, 1. So there you go. I can just keep going. So here's an interesting thing, which is that Pascal's triangle actually gives you combinations as well. So here's our n equals 0 line, our n equals 1, number of objects equals 2 line, number of objects equals 3, number of objects equals 4, number of objects equals 5, number of objects equals 6. Okay, there we go. Interesting. And this is the first one, so is going to be an r equals 0. This one here, r equals 1, r equals 2. Next, r equals 3, and so on. R equals 4, 5, 6. So at these top ones, it's the same. R is 1, R is 2, R is 3. Done. Oh, sorry, 0, 1, 2. Okay, I think you get it. So we're pretty much done. Only one more video to go after this one. So we'll leave it there, and I'll see you in a second.